So today I have a Raspberry Pi, and whenever I plug it into a PC, it automatically runs a script by itself. A few moments later, I get a message on Telegram saying, "I am ready." And from that point on, I can control that computer from anywhere in the world. For example, my laptop is currently sitting in my office right now. I'm not near it, and I'm not connected to it directly. I still have complete access to my laptop. I can open directories, see what's inside them, download files from the machine, and even manage files remotely. For example, I asked it to show me everything on my desktop, and it instantly listed all the files and folders. Then I asked it to remove the shortcuts, and it completed the task without any issues. Now let's try something a bit more challenging. I'm going to ask it to clone a project from Git and set it up. Let's see if it can actually do it. And there it is. It successfully pulled the project and completed the task. That's pretty impressive. Since this is Hermes Agent, it can do much more than basic file management. It can analyze projects, execute commands, automate multi-step workflows, and perform tasks that would normally require me to sit in front of the computer. At the moment, everything you're seeing is happening remotely. I'm controlling it directly from my phone. So how is this tiny Raspberry Pi actually doing all of this? This is a Raspberry Pi Zero, which costs around $15, and one of its most useful features is something called Gadget Mode. Gadget Mode allows the Raspberry Pi to behave like a USB device when it's connected to a computer. For example, it can identify itself as a keyboard. I used that feature to automate the entire setup process. Instead of manually typing commands on the target computer, I stored a setup script directly on the Raspberry Pi. When the Pi is plugged into a machine, it detects the operating system, loads the appropriate script, and begins installing everything required for Hermes Agent. Once the installation is finished, the Raspberry Pi has done its job. I can unplug it from the computer and put it back in my pocket while the agent remains installed and continues working normally. To show what's happening behind the scenes, I asked the system to list all connected devices. As you can see, this HID device is actually the Raspberry Pi. The computer sees it as a keyboard, which allows it to automatically perform the setup process without any manual input from me. Before going any further, this setup is intended for computers that you own or systems that you're authorized to manage. The purpose of this project isn't to gain access to random computers. The goal is to create a portable deployment tool that can quickly configure your own machines and make them remotely accessible. So that's the basic idea behind this project. Now let me show you exactly how I built it, how the scripts work, and how you can create your own version from scratch. For this project, you'll need a Raspberry Pi. I'm using a Raspberry Pi Zero because it's cheap, small, and works surprisingly well for this. Of course, if you already have a newer Raspberry Pi, that will work too. Apart from that, you'll need a micro SD card and a way to connect the Pi to your computer. In my case, I'm using a micro USB to USB-C adapter, but you can also use a micro USB cable. The first thing we need to do is install an operating system on the Pi. For that, download Raspberry Pi Imager. It's the official tool from Raspberry Pi, and it makes the whole process pretty straightforward. Once it's installed, open it up and select the model you're using. Since I'm working with a Pi Zero, I'll choose that. Next, select the operating system. I'm using Raspberry Pi OS Lite because we don't need a desktop environment for this project. It's lightweight, boots quickly, and uses fewer resources. Now plug your SD card in the PC and go through the setup options and configure things like your username, password, time zone, and keyboard layout. You'll also want to enter your Wi-Fi credentials here. One thing worth mentioning is that the Pi Zero only supports 2.4 GHz Wi-Fi. If your network setup causes issues, the easiest solution is usually to create a hotspot from your phone or laptop and connect the Pi to that instead. That's exactly what I'm doing here. I'm using my laptop's hotspot running on the 2.4 GHz band. And don't worry too much about internet access. We only need it during the setup process. Before starting the flash, make sure SSH is enabled. That's how we'll access the Pi later, so it's important not to skip this step. Once everything is configured, click Write and let Raspberry Pi Imager do its thing. Depending on your SD card, this can take a few minutes. When it's finished, you'll see the boot partition appear on your computer. Now here's something that caught me off guard. Sometimes Raspberry Pi Imager creates the Wi-Fi configuration automatically, and sometimes it doesn't. In my case, it didn't. So I had to manually create the WPA supplicant configuration file, paste in my Wi-Fi details, and save it to the boot partition. If yours is already there, you can skip this step entirely. Once that's done, eject the SD card, insert it into the Pi, and power it on. Now we just wait for it to boot. Once the Pi has finished booting, we need to find its IP address. The easiest way to do that on Windows is by using the ARP- a command, which lists all the devices currently connected to your network. And here is my Raspberry Pi. Now we need to establish an SSH connection with it. I'll type SSH followed by the Pi's username and its IP address. And we're connected. At this point, we're inside the Raspberry Pi and can start setting everything up. The first thing I want to do is update the package list using apt update. After that, I'll install Git, since we'll need it to pull the project files directly onto the Pi. Once the packages are updated and Git is installed, we can clone the repository. I wrote this project to work on Windows, Mac OS, and Linux, and it's completely open source, so feel free to modify it however you want. Let's copy the repository URL and move back to the Pi. I'm going to clone the repository inside the /opt directory because that's where I want the project to live. And it also makes it easier to run automatically during boot. So I'll use sudo git clone followed by the repository URL and clone it into /opt/pi -ducky. Once the repository has been cloned, we can start the setup script. I'll run it using bash, followed by the script name. The script takes care of installing and configuring everything automatically. This includes Tailscale, Hermes Agent, and Rustdesk. In the demo at the beginning of the video, I only showed Hermes Agent, but if you don't need Tailscale or Rustdesk, you can easily remove those parts from the script. Now we just have to wait for the setup process to finish. Depending on your internet connection and Raspberry Pi model, this might take a few minutes. Once the script has completed, there's one final step. Hermes Agent requires access to an AI model, so you'll need to provide your own API key. To do that, open the configuration file, edit the authentication key field, and replace it with your own key. Once you've made the changes, save the file and shut down the Raspberry Pi. And that's it. The setup is now complete. When you're ready to use it, connect the Raspberry Pi using the USB data port instead of the power port. On the Pi Zero, the inner micro USB port is the data port, and that's the one that allows the Pi to act as a USB keyboard through Gadget Mode. From that point on, plugging the Pi into a computer will trigger the automated setup process we demonstrated earlier. So that's it for this video. I hope you found it interesting, and if you want to experiment with it yourself, you'll find everything linked in the description.